Welcome to my Unity channel. In this session we're gonna create another tool for Unity. If you did not follow along the creation of our waypoints tool, that is okay. Maybe you still can have a look at it if it's something for you. I'm actually gonna use the tool in this session, or in this series of sessions for creating the tool. But it is totally possible to follow along without having the waypoints tool. So yeah, it's up to you if you use it or not. So what we're gonna do in this series of sessions is we're gonna create a tool called Area, and to illustrate what it should be capable of doing, I just set up a really small little ugly dummy scene. So what we got here is a plane, our standard 3D our standard third-person controller, and a cube. And the cube is got a trigger and a short little test script. So if I now press play, we have our guy standing here, and as he walks in the cube, we get a message: you have entered the area. And as he walks out the other end, you have left the area. So this is really what this series of tutorials will be all about. We want to create areas that can function as that. So the use case could be, yeah, really anything related to game events, in-game events. If your character walks in a house and you want something to happen, like maybe it triggers a quest event, or if you enter a larger area, like you have whatever, you have like a village, then you have your village soundtrack, and you have an orc camp, and then you have this soundtrack for that, or yeah, so you basically can set up large areas. You can even nest areas, that would all be fine, and can just use them in order to trigger game events. Now, I've used here a cube. You can use any of the primitives from provided by Unity. But the problem is that you're fairly restricted. So if your village is not in a square shape, or if your house is not in a square shape or anything, then it gets tricky. And the thing is, it's fairly difficult to keep track on where exactly you entered your mesh or your trigger, where you left. So if you would want to have multiple triggers next to each other and just keep track, well, I left here and I entered the next one, so I want to do something. It's just really messy. Like, I've tried that before. It's not much fun. So what we're gonna do in this tutorial is we want to create an irregular polygon. So this is now a cube, but what if we just add a few more corners to it? Then we're already more able to adapt the shape of it. So there are, with the approach I chose, which is mainly based on the knowledge I got of things so far, yeah, like with that approach, we will be still limited a bit, but it will definitely work better than a cube or all the other primitives we got here. So I'm just gonna delete everything except the waypoints tool. So that's all there is to it. That's how we finished off in the last section of creating the waypoints tool. So I'm also going to delete all this. We don't need a third-person controller anymore. And there we go. So the first thing we want to do now is set up the structure. If you do not have this folder and the waypoints tool, just create a new folder in the root path. I'm gonna create a folder here called area, and with an area I'm gonna create a folder called scripts. And in scripts, we're gonna create a C# script called area script. And I open that up in MonoDevelop. So if you followed along the Waypoints tools series, then you need to add the namespace for it. Just use the namespace you chose. And there we go. We don't need the update function, but the way I want to set it up is actually that on start our 3D object is created. So here we need a public void. Let's call this create area. And the way I want to do it now is just go through the list of functions that we will need in order to set up our entire object, and then we are going to fill the methods. So here we need a call to our create area function, and this is now a bit nested set of nested functions, but that's just how I choose to do it. So let's call this create irregular polygon. And of course we're gonna call this one in our create area function. And this is basically the function where everything is gonna happen. The whole creation process. But we are gonna call a few functions from here. So there's a few things that are gonna happen here. I'm just gonna write it in comments for now. So we're gonna create our mesh object. Then we're gonna add the vertices. We'll just get into that soon. We're gonna add the tries. We're gonna yeah, we need a mesh filter set up, and at the end we'll give it a material to look like something. So with creating a mesh in that way, programmatically or procedural, however you want to call it, what I found is if I look at other people's code, code from a different developer, I usually understand quite a bit of it, but often there are a few things, especially if there's if it's getting more complicated, where I just do not understand what's happening there, and I would need to try it out in order to get it, or just take the script as is. So what I'm going to try to do in this tutorial series is to break it down to the bare minimum of what we need to create our own mesh. And yeah, I hope I will try to do it in a way so you can follow along, which will mean that we'll have not the nicest dry code. So there will be some duplicates and stuff, but it will keep all the sections separate. So for example, we're gonna create create a different section for our bottom plane. We will create a different have a different section of code for our top plane, and the sides as well of our mesh. Just so there will be duplicates, just in case you're wondering, but it's meant to be a bit more organized, a bit easier to read actually. I hope that works. So yeah, this is our basic structure of how we want to move, and now we just need to yeah, fill it in. So creating a mesh is fairly straightforward. It's nothing more or less than saying a new mesh, or mesh is new mesh. And we're gonna give it a name. And this is irregular polygon. So this name is not the name. Sorry, this name is not the name of our area. This is just the name of the mesh. In case you're wondering, we will find a nicer, more descriptive name for our area later on. So I'm just gonna skip those for now and gonna focus on these. That will help us to see something in the process. So with the mesh filter, there's actually something we can do first, and this is a require component statement on top. So we just can tell Unity that this script requires a mesh filter. Oh, it doesn't need a semicolon at the end. And with that, I'm just gonna add another one right away. Require component type of mesh renderer. So we're just gonna quickly look what that does, and then we can have a look how to move on. Something's missing. Oh, my bad. Of course, this needs to be within our namespace declaration. Sorry about that. So I just saved the script, move back to Unity, clear the console of all the demo errors, and we're just gonna have a quick look what that does. If I create an empty and I pull on our script, you see right away a mesh filter and a mesh renderer are created with standard settings. So this comes in quite handy. The requirement component statement does add it if it's not there, and if it's there, it doesn't do anything with it. That's quite a neat feature. And yeah, we can delete this object again. Or actually, let's just have a quick look. If we have a 3D object, a cube, what each of those components does is the mesh filter. If you look at it, the only public variable it has is a mesh. So this is what we're gonna create now. That means our mesh filter holds all the information about our mesh, all the vertices, all the tries, all the UV coordinates, and all the normals, all those things. Even more, like there are lots of cool functions in there and stuff you can do if you know how to use it, which I don't. So we're gonna focus on the basics. But this is important to know. So without this component, our mesh does not have any data to work with. And the mesh renderer on the other side, that's fairly straightforward as well. This is the thing that makes our mesh visible. So as you can see in our scene view, without the mesh renderer, we still can see a mesh. It's still there, all the data still exists, and the data has a position and everything. So each vertex has a position, the faces have data and all this stuff. But in our game view, we don't see anything because our mesh renderer is disabled. So the mesh renderer does create or make our mesh visible. Camera setup weird. Don't know what that's all about. Doesn't matter. We don't really need the game view in this tutorial series that much. So this is what we need those two components for. Now we can delete the cube. And that being said, means we do not need to create a mesh filter here because it's already created by Unity if it's not there. And the nice feature about this is if we want to update our 3D area, we do not need to have an update function. We can just create it again. And this will overwrite all the data, but the mesh filter and the mesh renderer and all this, because it's there already, Unity will just use it instead of creating it new. So, sorry, there was a short break. I always wonder why people are always ringing the bell when I'm recording, and I've never seen that in any other video, but yeah, maybe other YouTubers just cut those things out nicely. Anyways, back to our mesh filter. So we get the component mesh filter, and all we need to do with that one is to assign the mesh. So this is our newly created mesh in this function. We do not have to do anything with the mesh renderer. The mesh renderer uses the data, and it comes with standard settings, so they work for this tutorial all right. Material, we're gonna create one as we go. And here we're also just gonna use the standard settings. So we create a new material that takes a shader, and shader has a function to find shaders by name. And if you've seen that, we're gonna have a look at that in Unity quickly. So if we create a cube, you see always this default material, and all that has is a shader, a standard shader. So this is the name of the shader. This is what we're referencing in our find call. And the material we created as that, just a new material. So no, I was a bit too hasty. We actually do need our mesh renderer. Get component mesh renderer. We need to set the material. Sorry about that. And here we do not need the game object. That works this way. So now all we need, which is still a fair bit, all we need is our vertices and the tries. How that works and what that is, we'll look into that. But as soon as we have them, we can press start, and we will actually see already our plane or our mesh or whatever we create, really. So these are really the basics. We do not have applied any texture or anything with it. The material is plain gray, diffuse standard material. So there's nothing special about it, but since we want to use it for an area, it will be a trigger, it will be invisible in the game view. That actually mustn't bother us. So now what we need to get started is a public array of game objects. I'm gonna call this points. And what that will do is if it works. Yeah. Here we have our points area. Now what we could do now is create empty objects, and they can be parented, it doesn't matter. We could duplicate that and move that around, duplicate it, move it around, duplicate it, move it around. So now we would have sort of a square shape here. And you can do that this way. If you do not have the waypoints tool, just do it like that. That works perfectly fine with our script. You just would need to lock the inspector, pull them in on your points, and you got them all assigned. Now, since we got the waypoints tool, I want to add a few lines of code to our script that will make it easier. First of all, I'm gonna do a require component call type of waypoint script. So again, that means if we pull in the script on an empty object, it will right away create a waypoint, add a waypoint script component to the object. And in our create area function, I'm gonna get a reference to this waypoint script. And I'm gonna set the points to our waypoints. So waypoints is a list of game objects within our waypoint script, and I'm just gonna create an array and store it in points. So this is just another way of setting our points. It's really need to create a new one here. It's really not much more. If you look now, we have our first waypoint, and I can add it. Add two more. One is here, another one is here. So this could be our first shape. We can close it. So this would be basically the bottom plane of our polygon. And if I now hit here, our area script still doesn't have any points, but if once I hit play, you see our standard material with the standard shaders created. Our waypoints are passed onto our area script. Everything is working fine. But again, you do not have to use the waypoint script. You can set this just as empty game objects. That doesn't matter. Okay, now how do we create a mesh here? So as our function already indicates, we need vertices and we need tries. So vertices would be those corner points. We could also add some in between, but basically that's the necessary vertices we need for our mesh, those corner points. So having this shape, we would need 4 corner points. If I remove one, we would only need 3. 3 is kind of the minimum, because otherwise there's no face that we can fill with anything. And another thing that Unity requires to create a mesh is tries. So each face is always made of tries. I think, I'm not fully sure, didn't test that. Let's just have a look at the quad. Okay, that doesn't work at all. Let's look at the plane. Now here, if you look at the plane, you can see all those quads, and each quad is made up of 2 tries. We have number 1 and number 2. So this is a good way of creating a mesh. You set it up, have a grid, and then have same size tries. That's actually quite helpful. Yeah, so if we look in the vertices, this object holds. So this would be one. We would have one here, here, here. So all these would be vertices, and each triangle is one of the tries. Or yeah, I guess tries is just too short for triangles. So this entire mesh is made up of quite a few triangles, and we want to create it in a similar way as we want to create our own mesh. So if we would have this shape, we would have 1, 2, 3 vertices and one triangle, or yeah, try. So let's just have a look at how to do this. So we would have a triangle, and we would have the indices 0, 1, 2 for our vertices. So that's very straightforward. If we now would have our tries, this is how it would look like. So basically, in setting the tries, you just create an area of ints, and there's always those triplets. So one triplet is one, defining one triangle. If we would have two, then the array would just continue, but you would read it as triplets. So always the tries array needs to have the amount of integers as a multiple amount of 3. So if we now had a quad, or yeah, then it would look like this. We would have, of course, one more vertex, but for our tries, that actually means we would need to have 2 tries already. So let me just quickly choose a different color. Okay, so that would mean we could, this is up to us how we divide it, and this is what we need to think about as we want to create an irregular plane. Excuse me. So we could say we're gonna divide it this way. So we would have 4 vertices and 2 tries. The first try being 0, 1, 2, the second try being 2, 3, 0. And now with the tries, it is important if you're going clockwise or counterclockwise. Going clockwise means that the normal will stick out towards the screen right now. Counterclockwise means the normal stick out the other way, or the try is actually flipped around. And this is important because if we move back to Unity, if we create another plane, if you look at the plane from the bottom, okay, that will not do much. Let's create a cube on top. Now, if the cube is underneath, and I don't have it selected, we do not see the cube through our plane. If we look from the other side, though, we can always see the cube. That means that only the tries are only rendered on one side. If you want them to be rendered on the other side, you need to add another try with the counterclockwise numbers. So that is one thing that is important with tries, and the other thing is the array really references the indices of the vertices. Oh man, lots of weird words, but if I put that in, so we would define in an array that we have vertex 0, vertex 1, vertex 2, vertex 3, and then we would have our tries array where we just put in those integer numbers, and those numbers are the indices in our vertex array. So 0 is referencing the object at index 0 in our array of vertices. I hope that makes sense. And as I said, we would have 2 tries now. I just left a little gap, but it doesn't matter for an array. As you know, it's just I just want to visualize how two tries that are set in this area of numbers. So this is still okay, but what if we just add any given number of vertices to our area or to our plane for now? I just created, sorry, I just need to remove that. So I just took one with 5 vertices now, 6 vertices, and it's an irregular shape, no straight or parallel lines here. And now it's basically up to us how we want to divide this face in many triangles. So that's the wrong tool. So we could start again 0, 1, 2, and then we could start 2, 3, 4, and we could say 4, 5, 0, and 2, 0, 2, 4. So this would work, but basically we need to find a way to put this in a simple algorithmic pattern, and this one would not really work in a simple way. As if you add more, you can try it out. If you add more vertices, you just get confused. So I've chosen a fairly simple method for this tutorial series. It comes with some limitations, and I might change it later on, but for now we're gonna work with that. So what I'm gonna do is I start with 0, and from here I'm gonna draw this imaginary line to each of the other vertices, not including the neighbors obviously. And so we would have one triangle 0, 1, 2, 0, 2, 3, 0, 3, 4, 0, 4, 5. And as you can tell, this is fairly straightforward in numbers, and this will make it possible to easily put this in code. So written down, it would look like this. So this would be our array of tries, or integers of try array. So now that's quite a bit of theory, and we're actually gonna do this in the next session. We're gonna add this to our code. So thank you for watching. I hope these background information help you, and I hope there was something new, something you could learn. And in the next session we're gonna put it down in code, and it'll get more visible, more understandable, hopefully. Well, thanks for watching, and see you next time. Bye.